I'm Rajesh Kanan from the AADS department. I'm going to present about my project Parkinson Disease Prediction System. These are the agenda of my project. Parkinson disease is a chronic progressive neurodegenerative disorder. It affects the motor system, which may lead to the decline in physical activities and making everyday task difficult. We developed a machine learning predictive system that helps in early detection of Parkinson disease, and it provides a non-invasive automated tool that can assist medical professionals in identifying potential Parkinson cases and improving early diagnosis and treatment strategies. And as I mentioned, it's a neurodegenerative disease. It's crashing because of loss of dopamine producing neurons. And we have vocal data of Parkinson disease infected persons. And we will provide the timely, accurate prediction whether the person has Parkinson disease or not. If and early detection of Parkinson disease may lead to improved quality of life of patients. And these are the scope of our project. And we used various machine learning algorithms like SVM and random forest for better accuracy. And target audience are medical professionals, healthcare institutions, and researchers in neurology. And we provided a user-friendly interface for model deployment. And impressions, we collect the data from patient records and the relevant feature, and we developed a hybrid model system. And the exclusions are we can directly get all the features of Parkinson disease, and something like we can't only say whether a person has Parkinson disease or not by his only vocal values. We should have multiple tests, multiple checkups. Then only we can say whether the person 100% we can say whether the person has Parkinson disease or not. And this is one of the exclusion of our systems. And data we have used is available is created by Max Little from the University of Oxford. And here there are 25 vocal features. We have taken only 8 important features that are relevant to Parkinson disease. And we pre-process the data for misconsistency and outlier deductions. First, we collect the data from we have collect the data from both infected individuals and as well as the healthy individuals, and it will be used for validating and training our model. And we pre-process the vocal data, and we ensure whether it will suitable for analysis. And we feed the pre-processed data to hybrid model of SVM and random forest, which are with the hyperparameter tuning. And we have web app deployment, which will provide healthcare professionals with easy to use interface. Users will be able to upload their voiceable data and quickly receive prediction regarding Parkinson disease classifications. The app will be built using the Streamlit Pickle libraries for which will be used for modern, responsive, and secure interface. This is the architecture diagram and use case diagram. This is the class diagram, sequence diagram, and the algorithm we have used, as I mentioned, SVM. It is a supervised machine learning algorithm used for classification tasks. And here we find the optimal hyperplane that separates the data plane from different classes in high dimensional space. And SVM is effective in high dimensional scenarios and robust to overfitting due to its use of kernel functions. It can handle both the linear and non-value classification problems. Random forest. Random forest is an ensemble learner that build multiple decision trees and merges the prediction into enhance accuracy and stability. By combining the output of several trees, random forest reduces the risk of overfitting while also providing insightful into feature importance. It's capable of handling both classification and regression tasks, performs well with a mix of categorical and continuous data. Voting classifier. Voting classifier is a meta classifier that combines the prediction of multiple base classifiers such as SVM and random forest to produce the final prediction. In this project, the soft voting method is used, which averages the predicted probabilities from each classifier to determine the final output. This approach taken into account the confidence of each classifier, often resulting in improved accuracy to individual classifiers. These are our basic hardware and software requirements. These are the implementation. The project is implemented using Python libraries such as Streamlit, Pickle, and Skillet. Skillet. This is the main important code segments of data. Here we import the important library. We loaded the data, and we splitted the data. We using smart transformation to handle the class imbalance that will use to reduce the class based distribution in the data set. We train the data set and we use the scalar standard scalar for transformation. We use PCA for dimensionality detection, and we take the hyperparameter for random forest optimal hyperparameter, and using the search we will find the best random forest. Okay. Here we is using the same method hyperparameter for SVM with kernels such as linear, RBF, and poly. And here we find the best SVM model, and we combine both the best optimal hybrid, best optimal random forest and SVM model. It's testing data we have provided. This is the output interface. The model has actual accuracy of 92%, precision 93%, recall value of 92%. And sustainable development goals, early detection of and management of Parkinson's disease through advanced machine learning techniques, ensuring accessible and accurate healthcare for particularly in underserved communities such as in African side, we can implement this kind of projects. Our experiment demonstrate that the hybrid model combining SEO nanometers improves the accuracy of Parkinson disease prediction. The hybrid approach enhances the model's ability to generalize unseen data, which is crucial for practical applications in the healthcare. These are the reference. Thank you.